Now let's look at part 2. So given that theta is sufficiently small, so let's say theta is sufficiently small, okay, show that AC is equals to 1 plus A theta plus B theta square. Okay, so this is important. So the first thing is you need to know that when it's small, let's say it's a small angle, let's say 0.01 theta, right? So that's why T cube will be like negligible, 0, 1. Theta 4 will be even worse, like it will be smaller. So this is like very close to 0. Not really, but in grand scheme of things, it's like very negligible. But anyway, the clue is you see that this tells you that ignore theta cube, okay, because it only expands on theta square. So that's the clue there. Now, how do we then derive that? So from our standard series, we know that. So just take our standard series here, which is the standard series. We know that sine theta is x here. This can be ignored. Okay, cosine x theta here, which means we just need to ignore until theta cube. So this one we need to take square in. All right. So from the standard series, we know that these are the ones which are here. So we're gonna do that by putting in when sine. So everything is just in the standard series. Okay. So in other words, sine theta from MF 26 standard series. Okay, sine theta will be equals to x theta here. Sine theta will be equals to theta, and cosine theta will become 1 minus theta squared over 2. So become 1 minus theta squared over 2 factorial, which is 2, right? So in other words, from the first part, we know that we're going to use AC equals to 1 minus theta here. Cosine first, okay, 1 minus 2 minus theta. Okay, so this is roughly equal. So what I did was I just sub this inside here. Right, so once this is done, life is good. What we need next is essentially just change this to what do you call it? The inverse. I mean this form here, so that we can use power series. Okay, because this is not the form we need. We need it in ascending power as such. Right, so we need it to be theta plus theta squared. It's a polynomial. So in this case here, it's not a polynomial here. So I need to arrange this here. Now this is a power series. What we need is actually to segregate this. This is using 1 plus x n equals to nx plus 2 factorial. This is from MF26, right? So if you look at MF26, you have this power series here that you can use. Right, so I'm going to use that over there. That will be great. So this case here, what we're going to get is actually just separate the x there. This is 1 minus theta. Okay, maybe I just put this plus theta squared over 2. Okay, so this case here, this is my x. This is my x here. So if I would use the power series, this would be 1 minus 1 minus theta plus theta squared over 2 plus n, which is negative 1, negative 2 over 2 factorial. And I'm going to just square it. That's it. I can ignore the power 3 because I don't really need the power 3 there. So once that's done, we could just expand this part. It looks a bit complicated, but I think it's okay. 1 plus theta plus half over theta square. This will be minus 1. Or this is plus or minus 1 because it's squared there. This will be theta plus half theta square. But because we only need the what do you call it? we only need oh, this is positive, sorry. This is positive. Minus 2 times 1, this is positive, this is positive. So we only need the lowest power. You don't need to expand everything. The middle term is theta square, theta cube, and theta power 4, but we only need theta square. So this case here can just ignore. So this is theta plus half theta square plus theta square. Okay, so that's how we do this part. This is 1 plus theta plus 3 over 2 theta square plus dot dot dot. Okay, there you go. So once that is done, we know that A is equal to, what is our A? A is actually we just want A, which is this one here in front of theta. So 1 equals to A, and B equals to 3 over 2. Okay, now this is how I do this question here proficiently. If you have any questions or comments at all, please let us know. Keep practicing, and I'll see you in the next question.